So for these problems, when the problems are written this way, we're going to say, yeah, okay. So it's kind of a 3-step process. So the first step of the process is to rewrite all radicals in exponential form. So convert everything into an exponent. Use exponential. She wasn't sure what I meant by EXP. Yeah, that's what I'm shorthanding it for. Use exponential form, use your exponential rules to simplify So just a couple reminders with our exponential rules. If we have x to the a times x to the b, if we have something like that, then that would be x to the a plus b. You add your exponents together. If we have x to the a over x to the b, then this is x to the a minus b. You subtract your exponents. And if you have x to the a raised to the b, this is x to the a times b. So those are the 3 exponential rules that we're going to use. So the first thing we're going to do with the problems is we're going to take all the radicals in the problem and put them in exponential form. Then we're going to use our exponential rules to simplify as much as we can. And then we're going to write in simplified radical form. So what this means is once we put it in the radical form, back to the radical form, we might have to simplify it again. Lots of simplifying. It's going to be so fun. Okay, so those are our 3 steps. So our first example, who wants to answer the phone and have them tell me to take my attendance? Marvelous. Say, Miss Rice's room, student speaking. It's not about taking my attendance.
I just told my teacher to call you at the beginning of the class.
Oh my gosh, that'd be a good prank, but it would be terrible. All right, here we go. First problem: x to the 1/3 times x to the 4/3. So we don't even have to convert this into exponential form, which is the first step, because this is already in exponential form. So this is not bad. So first step is to rewrite into exponential form. We're already there. Second step is to use our exponential rules to simplify as much as we can. So if we have x to the 1/3 times x to the 4/3, what exponential rule are we going to use? What do we do with these? What do we do with these exponents? You add them. So we're going to say 1/3 plus 4/3 is 5/3. Okay, this is x to the 5/3. Okay, so we have simplified it as much as we can using our exponential rules. And so now we're going to convert it back into the radical form. So if it says 5/3, then what type of radical is that? It's got a 3 on the bottom. It's got a 5 on the top. It's a cube root. X to the 5th. Okay? And then if we're going to simplify this now, how could I simplify an x to the 5th underneath a cube root? Jay, go ahead and put your Chromebook away, all the way away. Okay, so I'm going to write 5 out. I got a group of 3. So should I say x to the 3rd for the triple?
No,
It's just x. So I'm just going to say this represents the triple is just x.
I'm saying like on the outside.
Oh, cube root. Okay. And then what goes underneath? What did you say? X squared. Perfect. Okay. So x cube root x squared. That's the answer. Now, we can't really check this in our calculator because our calculator doesn't let us check expressions this way, but what we could do is we could take the calculator and plug in a number for this expression and plug in a number for this expression and just make sure they end up equaling the same thing. So, and this is kind of a neat trick in the calculators to be able to take something and evaluate it in for something else. Christy, if you want to sit over there, you can, and there's already a calculator over there. Do you still have your cheat sheet? Did you turn it in here? You want to grab it? Okay. So what we're going to do is everybody grab your graphing calculators. We're all going to plug in a number, and we're all going to plug in a different number, okay? So everybody, we're going to plug in positive numbers just to make this a little bit easier. So I want you to type any number on your screen. It doesn't matter. I'm going to type a 9. So plug in any number you want. It doesn't matter what number. You can type in a 1-digit number like I did, or you could do a 2-digit number, 3-digit number. It doesn't make a difference. And then once you plug in your number, you're going to go down here to the store button right here, STO. And we're going to store as x right here, as x. So now you should have your number goes to x. X is right up here. Everyone have that? Okay. Now press the enter button. So what we just did is we all stored our different numbers in for the x key. So now if you hit the x button and press enter, your number is going to pop up. Everyone have that happen? Okay, so now what we're going to do is we're going to type in the original expression and we're going to see what number we get. We're going to type in our answer expression and make sure that it equals the same number. Okay, so I'm going to type in x to the 1/3, so x to the, so I'm going to do the up arrow, x to the 1 divided by 3. It doesn't matter if we type it in as a fraction, this is fine. So x to the 1/3 times x to the 4/3. Now we're all going to get different answers because we all use different numbers. Okay, so I'm going to press enter. I'm going to get my answer. This is what I got. Everyone got their answer for that one? Okay, now I'm going to type x cube root x squared. So I'm going to type x. To get my cube root, I have to hit the math button. And then the cube root is down here. It's number 4. Cube root x squared. So x cube root x squared. And if you press enter again, you'll get the same answer. Doesn't matter what number you stored. We're all plugging in different numbers, but if we did this right, we should get the same answer. Let me see how you plugged it in.
Oh, I know why. Because I put it well, actually, because I put it in as I clicked that, or I put that.
Oh, because you didn't get out of, you're in there as an exponent, looks like.
So I have to.
Yeah, okay, so I'm going to put this in again. Okay, now we're going to do x and hit the math button. There's your cube root, x squared. Okay, see how it looks different?
Okay.
You were in the exponent position when you typed yours. And they're the same.
Thank you.
Okay. All right, let's try another one. So even though you can't type in the expression and see that it popped out that, yes, the expression was the same, you can plug in a number and that can prove that they were the same. Yeah. Oh, the whole, hold on, there we go. Okay, here is the next one we'll do.
So if we put the x 1/3 times x 4/3 in the calculator, and put the final answer in there,
It should be the same. And so you can see here is me doing it. I stored 9 in my calculator, and then I typed it in, and it gave me the same answer. So what it was doing was it was plugging 9 in for x. Okay, let's try another one. So I'm going to do p to the 1/4 times p to the 3/2. Okay, so again, they started off kind of nice for me. They put it in the exponential form to start with, so I didn't have to convert it into exponential form. And so now we're going to use the exponential rules. And with this problem, what do I have to do with my exponents? I have to add them together. I have to take 1/4 and add it to 3/2. If you don't feel like doing that in your brain, you can just do 1/4 plus 3/2. So I'm doing this with just the division key on my calculator. 1 divided by 4 plus 3 divided by 2. Gives me a decimal, but if I hit the math button on my calculator, hit the math button, the first option is frac, which will take whatever decimal you have on your screen and turn it back into a fraction for you. Okay, so that's one way you can plug it in. Another way you can plug it in is you can do alpha y equals. If you type alpha y equals, that will allow you to type it in as a fraction. So we could do 1/4 plus 3/2. And then if you do that, it will spit out the answer as a fraction. So 2 different ways of typing it in. 1/4. 1/4 and 3/2. And so what is our resulting answer now? P to the 7/4. Okay. To take a decimal and turn it into a fraction, you would hit the math button, which is right underneath the green button, and press enter on number 1, and then it'll turn it into a fraction. Okay, so now we're going to do step 3 and convert this back into a radical. So what type of radical is this? Not a cube, it's a 4th root. And what do we have underneath the 4th root? P to the 7th. Okay, so to simplify this, I'm going to write out 7 p's. And then when I look for my group, how many should I group together? 4 of them. So p times the 4th root of p cubed. And if I want to check my answer, I don't even have to store something new for x. I could leave what I had stored for x before. I could do x to the 1/4 times x to the 3/2. Okay, now I'm going to type x, and then to get the 4th root, this is kind of interesting to type in your calculator because your calculator doesn't have something that's 4th root specifically. So I type an x first, and then I have to type a 4, and then I hit the math button, and I go down to option number 5, which says x root, and it's going to take that 4 that I just typed, and it's going to put it in the radical for me. Ooh, it put the x and the 4. Delete. Go back. Put an x. There we go. I didn't want the x and the 4 in there. Okay, so x 4th root, and then x to the 3rd. Same decimal, so I know I got it right. Okay, You don't have to check your answer like that on every problem, but if you get to one where you're not confident in your answer, it's a good way to check it. Do you have to what? Nope. Nope. All right, next one. M to the 5/2 over m to the 7/4. So this one is already rewritten as an exponent. If we use our exponential rules, what are we going to do? Gracie, you smiling at your paper? Let's put the cell phone all the way away so you're not tempted to use it. You can sit at that back table. Okay, we're going to take the exponents and subtract them. So I'm going to do 5/2 minus 7/4. I get 0.75. Hit the math button, press enter, 3/4. Okay, so that's m to the 3/4. Okay, how do I rewrite this as a radical? Fourth root. Yeah, fourth root m cubed. Okay, if it's a fourth root and this is m to the 3rd, can this be simplified? No. So we're just done. Okay. Let's do a to the 1/3 raised to the 5/2. A to the 1/3 raised to the 5/2. So what do we do with the exponents? Multiply them. How do you multiply exponents together without a calculator? You do it what?
Make sure they have the same denominator.
You don't need the same denominator, that's adding and subtracting. So it's a little bit easier than that. You multiply straight across. So we're going to multiply the tops, and what do we get? 5. We multiply the bottoms. 6. Okay. So now let's go ahead and write this as a radical. What type of radical do we have? 6th root. Okay. A to the 5th. Okay. If it's a 6th root of a to the 5th, does it need to be simplified? Nope. Done. Okay. All right, we're going to do this one. The square root of the square root of 32. The square root of the square root of 32. It's very strange. Aubrey just threw up a little bit in the back of her throat. Whew, it's weird. So this time we have to do step 1. What's step 1?
Take the first one. Exponential form.
Rewrite it in exponential form. So if we have a square root, what type of exponent is that? Not a 2, it's a 1/2. Okay, so we're going to have a 32. Is it just a 32 to the 1/2? Or is there more to it than that? So it's a 32 to the 1/2. That's this part and with a square root over it? Because that's the square root, right? Okay. Is this right?
You have to put 1/2 again.
A 1/2 again. So how should I write it with another 1/2? Put it on the outside. So it would be 32 to the 1/2 to the 1/2. That's what square root means. 1/2 to the 1/2. It's actually not as bad as it looks once we do the second step. So the second step says just multiply your exponents. Use your exponential rules, which means multiply your exponents. So if we do 1/2 times 1/2, what do we get? We get 1/4. 32 to the 1/4. Okay. So what type of root is this? Fourth root. Okay, we have a fourth root. So I'm going to say this is really just a fourth root of 32. And you could write 32 to the first power, but that's really just 32. And now we have to simplify it. And can 32 be broken down? Definitely. Okay. 8 and 4. 4 and 2. 2 and 2. 2 and 2. Okay. When we look for our groups, how many are we looking for in a group? We're looking for sets of 4. Okay, one set of 4 and a leftover of 2. So our answer is 2 4th root 2. So apparently square root of square root 32 is 2 4th root 2. Okay, let's try. This one we're going to have 8x to the second to the 2 third. What is the exponent for the 8? So 1. Okay, so we actually have 2 exponents inside. Okay, so we don't have radicals. It's already written in exponential form, so we're doing our exponential rules. And what do we do with the exponents? We multiply them. So 2 thirds times 1 is 2 thirds. Okay, and then I can write this as a fraction, this whole number. 2 as a fraction would be 2 over 1. Okay, and then if we multiply 2 over 1 times 2 over 3, what do we get? 4 over 3. Okay. So since these both have the same number on the bottom, we could put both of these things in the same radical if you guys want to. What type of radical would we use? Yeah, a third root. And then for the 8, what would we put inside? 8 squared. And for the x, what would we put inside? X to the 4th. Okay. What is 8 squared? 64? Okay. Well, you were saying cube root of 8. That's actually it's not the wrong way to do things. I'll show you something in a little bit. So, third root of 64 times x to the 4th. Okay. So, we have the 64. What should we do? Break it down. 8 and 8. 4 and 2. And 2 and 2. And then x to the 4th. Okay. So how many are we looking for in our sets? 3. 4 third root
Or not x squared,
Four.
x to the fourth, x to the fourth, right?
4x, because we have a triple here. 4x, and then third root x. Okay. Now, Gavin touched on something that was kind of brilliant. He didn't realize he was being brilliant, but he was. If we keep those two terms separate, you could do the third root of 8. And Gavin, I'm going to write it this way because this is actually kind of how you were handling it. Third root of 8 squared. And then I'll just leave this as third root of x to the fourth. Gavin said 2 before he thought he was doing it wrong, but he wasn't doing it wrong. So the third root of 8 is 2. Would you agree with that? Third root of 8 is 2. Because 2 times 2 times 2 is 8. So the third root of 8 is 2. Okay? So if we were using Gavin's accidental method, we would say that the inside of this is just 2. And then the outside of this is an exponent of 2. Okay? And then what is 2 squared? 4. Which way was easier, this method or Gavin's accidental method?
I try not to listen at once anymore.
That makes sense. So Gavin's accidental method is a little bit easier. The reason it's a little bit easier is because if you have something like this, and the reason it was kind of accidental but it kind of worked is because you can actually take the cube root of 8. So that doesn't happen every time. But if you look at it and it's something you can actually cube root, it's easier to do it this way because it's easier to make a number smaller and then make it a little bit bigger than it is to take something 8 squared, make it bigger before you make it smaller. So if you make it smaller first, then you're working with more manageable numbers. This is a strategy. It doesn't mean you have to do it this way. But this method, if you can remember it, it's nice. It's nice to think of them that way. Yeah. But that was good. That wasn't wrong. That was good. Okay. Let's try another one. We're going to do this one right here. Okay. We're going to do third root v times square root v. Third root v times square root v. So, how should I rewrite this problem to start with? Because it's not written in exponential form, so I do have to rewrite it. V to the 1/3 times V to the 1/2. Okay. I could not do this by hand the way that it's done right now. And Whitney, this is what you were talking about, where if you're working with these, you'd have to have a common denominator. So we're going to take these fractions, we're going to add them together. If you feel like getting a common denominator by hand, you could do that. I'm going to be honest, I don't. So I want to type this in my calculator. So how could I use my calculator to add these together? How do you guys want to type it? Do you want to type it as a fraction, or do you want to use the division key? Division key. So I'm going to do 1 divided by 3 plus 1 divided by 2. And then how do I get my calculator to give me a fraction answer? I hit the math button right underneath the green button. I hit the math button. First option is frac. And I press enter twice. So go ahead and do that on your calculators. Tell me what that fraction is. 5/6. Okay. So this is v to the 5/6. Okay. So what type of root do we have? We have a 6th root. Okay. What do we have underneath the root? V to the 5th. Okay. Does this need to be simplified? Nope. We're good. Okay. I'm going to let you guys work on the sheet. We're going to work on 11 through 22, and I want you guys to do as many problems as you can. You can leave the ones that you feel stuck by, and then I'll do some more example problems to kind of help you with the ones you're stuck on. Okay? So 11 through 22, you're just doing as many of those problems as you feel like you can get to.